Hey Murray, so I want to kind of walk you through that formula that I put on your post the other day because I realized that looking at it statically is probably confusing as hell. But I think walking through it kind of piece by piece will make a lot more sense. So it sounds to me like you're not entirely sure how many boards you want to use to make the polygon around the water tank. So let me explain part of the formula because I think that'll help by looking at like a pattern of increasing boards. So thinking about looking straight down at your water tank. So you showed me that picture looking from the front. If you look straight down at it from the top, it's going to look like a circle. Now it's not a circle. It's a polygon with a lot of sides. But looking straight down, you're gonna see that circular shape, but the angles inside that thing are going to depend on how many sides there are. I'm making the assumption that all the sides are equal, like you're going to use like 2x6s or 2x8s or something like that to make the distance all the way around. So knowing that they're all equal, that makes it what's called a regular polygon, which makes the math easier. So just like, for example, probably you could use a triangle. That's one shape looking down. You could use a square. You could use a pentagon. You could use a hexagon. And then you could use any number of, you just keep increasing sides, triangle, square, pentagon, hexagon, septagon, octagon. And so there's a couple things, like you might remember that a triangle has 180 total degrees inside. So that means this plus that is 180. That means each of those angles is 60. Okay, that's a square. They add up to 360. Which means each angle inside is 90. Pentagon, this is where it starts getting interesting. So 180, 360, how many total angles or how many total degrees does this add up to? And conversely, what does each of those angles have to be? Well, if we can figure out the total number of angles, we can just divide that by the number of sides to get what each angle has to be. Like 180 divided by 3 is 60. 360 divided by 4 is 90. What we got to do is we got to figure out how many degrees are in this. And it's funny, when you first sent me this problem, my mind flashed back like 30 years in the past, and I remember solving a similar problem like 30 years ago. And the way I did it back then was I divided, so we know a triangle has 180 degrees. If you actually divide up this square by drawing a line across the middle of it, you get two triangles. And then if you add up all those triangles' angles, you end up adding up all the degrees in the square. So you got 180 here and 180 here, which makes 360. And you can just keep doing that all the way along. Like for a pentagon, you draw two of them like that, and then you've got 180 here, 180 here, 180 here. So you end up with 3 180s, which I think is 540 if I did the math right. And that makes each of the angles 540 divided by 5, which is 108 degrees. And hopefully this all makes sense. Like, each angle is getting bigger because this thing is beginning to push out into the shape of a circle the more sides you have. And then we can do one more to get the pattern. So for a hexagon, you're going to have 1, 2, 3, so 3 diagonals, and that makes 4 triangles. So that's going to be 4 times 720 degrees total, divided by 6 is going to be 120 each. Okay. So what we want to do here is we want to make a general formula because you don't know how many sides you're going to have yet. At least that's what I got from your post, is you're not sure if you're going to have 18 sides or 19 or 20 or 21. So I guess what's fun about this is we can actually figure out how many degrees are going to be in whatever number of sided polygon you've got. So in other words, I think you called it X for X sides. Okay, X sides. So if we look at a pattern here, for 3 sides, you have 180 degrees. 4 sides, you have 360 degrees. 5 sides, you have 540 degrees, and so forth. So what's happening is with each additional side you add, you also add another 180 degrees. So what my brain first went to was, well, all I got to do is figure out how many triangles there are. So for 3 sides, there's 1 triangle. For 4 sides, there's 2 triangles. For 5 sides, there's 3 triangles, and this is a little bit easier. So for however many sides there are, 6 sides, there's going to be 2 fewer triangles. Okay? So for x sides, there's going to be x minus 2 triangles. So if you had 18 sides, you'd have 16 triangles. If you had 20 sides, you'd have 18 triangles. If you had 30 sides, you'd have 28 triangles. So if you think to that part of the formula when I wrote x minus 2 times 180, that tells you the total number of degrees in your tank, or in your, excuse me, in the polygon on the inside of your shape. So that depending on what you plug in for x, that'll tell you how many degrees will pop out here. So if you plugged in 6, you'd get 720, which means you'd have 720 total degrees in your tank, and so forth. Hopefully that much makes sense. So if that makes sense, then we can move on to the next bit. Now the next bit is to figure out the mitering cut, because we're not quite done yet. That's part of the answer. So let me clear some space here. So what I'm going to do is I'm just going to draw. I'm going to leave this up here. So we're going to come back to that. I'm just going to draw a polygon or part of the tank with no reference to the number of sides. I'm just going to draw part of it. So part of it's going to look like this. You're going to have a bunch of boards coming in, looking like this, and they'll be making a turn and, you know, going off, and, you know, I have no idea how many sides this is. I'm just making it in the general case. So we know that if we add up all these individual angles on the inside, all of them added together add up to that with x sides. So this is still x sides. That means that each one of these angles here, each one of these angles is this number divided by x, because there are x of the angles. So in a square, it was 360 divided by 4 to get 90, because there's 4 sides. In a pentagon, it was 540 divided by 5. So this angle right here, I'm just going to use this one as a reference point, because we can get the rest of what we need to get to from this one. This angle right here is x minus 2 times 180 degrees over x. So all you'd have to do is plug in the number of sides you have in your construction, the number of sides you want, plug that into here, and that tells you the measure of that angle right there. And then I realized that the formula I gave you isn't very helpful, because I said then divide that by 2x, but what I should have done instead was not talked about that angle. Your question was about this. Your question was about these angles here in the miters of the 2-bys. I'm assuming you're going to use 2-bys. The miters that you have to cut those angles at. So what we really need to do is something fairly straightforward. It's going to look terrible mathematically, but it's actually fairly straightforward once you start plugging values in. So I'm going to draw a line here. And this line is going to be the extension into the middle of the tank. You wouldn't actually build this. This is just for the planning purposes. So what I've now done with this line, this is where the miter cut would be between the 2 boards that join together. I've taken this angle and now cut it in half. Okay, so that's the part we talked about. So this angle right over here, this part right here, is that number. So in other words, remember, if it was a square, it was 90 degrees. If you slice that, it becomes 45-degree angles on both sides. For a pentagon, it's 108 degrees. If you slice that, you get 54 and 54. Hopefully that makes sense. Now, whatever that angle is, you're going to want to set your miter. Now, this is depending on how your miter is set up. That angle will be equal to this angle right here. These are parallel lines. So whatever that angle is will be equal to this angle here. And I'm thinking that's the one. That's why this formula works. I just wanted you to make sure that you actually saw why it worked. That angle equals that angle. So if that's a 45, you'd set this miter over here to 45 and cut it at a 45. If that's a 54, you'd set that miter to 54 and cut it at 54. The trick is, as as the X gets bigger and bigger and bigger and bigger, this angle starts getting pretty close to 90 degrees. Because those boards they're not like a square or a pentagon or a hexagon. They're starting to really level out. They're never going to get to 180 because that would be a straight line, but they're getting pretty darn close. So you're going to have a pretty tight miter there. Very, very close. As a matter of fact, by the end of the day, you might view that this is all not even worth it. You might say, to hell with it, I'm just going to butt them up next to each other and not worry about the miter. But if you're like me, you'll be like, no, I'm going to miter that 89.2 degree angle or something like that. So anyway, the point being is this little formula right here. Whatever that angle is on the inside is mirrored over here on the exterior miter. Now, if your miter's set up the other way, what you're going to have to do is you're going to have to miter the inside of that. So all that is it's 180 degrees less than, or 180 degrees away from this one. So if this one was 45, the one on the other side would be 135 because they make a straight line going across. But I don't think that's how most miter boxes are set up. It's the ones I have, the old school ones where you put a handsaw into. They're usually you miter between 0 and 90. And if you need 135, you just do a 45 and flip it over. So that, I think, is going to be the easiest way to get the miter. I mean, granted, it's a pretty nasty looking little formula, but I also wanted you to see how it worked. So I hope that made sense. And shoot me a note on Facebook if it doesn't. Talk to you.